Hello, statistics students. Welcome to another video on modeling linear trends, interpreting the slope. Once we've established that the mean value of y depends on the value of x, a good statistical question to ask is, how do typical y values compare for different x values? When the association is linear, the slope provides an answer to that question. The slope tells us how the mean y values compare when the x value are 1 unit apart. Slope is always rise over run, and so it's a number over 1, and so it says as the x value is 1 unit apart, then the y value changes by that slope. For example, how different is the mean percentage of students in high school who smoke when we look at a state with 1% higher of smoke-free homes in a state? The slope in the video in for example 7 tells us that the means differ by a slim 0.464, as you can see in the figure below. Remember that slope was negative 0.464%. What if we look at a state with 10% more smoke-free homes in a state? Because the 0.464 tells us the change for a 1% more smoke-free homes. But what if it's 10%? Then the mean percentage of students in high school who smoke is 10 times lower, or 10 times 0.464, or 4.64% lower. We can see that in a typical state, if we want to decrease the percentage of students in high school who smoke by 20%, we would need to have a state that has about 43% of smoke-free homes more. 43% more smoke-free homes, because 43 times 0.464 is about 20%. We should pay attention to whether the slope is zero or very close to zero. When the slope is zero, we say that no linear relationship exists between x and y. The reason is that a slope of zero means that no matter what x value you consider, the predicted value of y is always going to be the same. The slope is zero whenever the correlation coefficient is zero. For linear trends, a slope of zero means there is no association between x and y. And this concludes this video on modeling linear trends, interpreting the slope.